Hey there friends and folks! Today I want to go over a basic torch setup, but I also want to show y'all how to make your own headpins using said setup. Having a basic butane torch setup can allow you to do so much more with your silver and copper work that I can honestly say investing in these tools is the most worthwhile jewelry related investment I've made. I don't necessarily use my torch on every piece that I make, but it helps me do a lot of very simple things that I would have no way of doing otherwise. So for your torch setup, you'll need some kind of metal sheet to go underneath the entire setup. You'll need a fire brick. You want special pliers that are for metalwork and torch work, a heat-resistant quenching bowl of some kind, your butane torch, and your butane. It also doesn't hurt to have a paper towel underneath that quenching bowl. As far as safety goes, you'll always want to pull back any loose hair or clothing, as well as wear protective glasses just in case any molten metal spatters. But from there, let's talk about this torch setup piece by piece. So the torch that I use is this wired jewelry microflame butane torch. When I was working at the bead store, we offered 2 torches for sale, and the reason I picked this one was because handling it felt the most natural to me. All microflame butane torches will work essentially the same, but like any other tool, where the placement of certain buttons and knobs are can vary. This torch felt the most intuitive to me, so I bought this one. I actually have 2 of these torches now so that I can achieve a higher and more consistent heat when working with thicker gauge sterling silver, fine silver, and some copper. And over my 8 years of torch work, I've only had to replace 1 of these so far, though it might be time to replace the second. So on this torch, you have your gas release, your ignition, and your lock. This knob here actually controls the flow of oxygen to your flame. And when you open it up and align these holes, you're allowing more oxygen to flow to your flame, and your flame will become more intense and more precise. As you rotate those holes out of alignment, you're restricting the oxygen flow to your flame, and your flame will become more feathered. I'll use this restricted feathered flame for heat patinas because it's less directed and less intense, whereas I'll use the pointed flame for fusing, making headpins, or really anything where I'm trying to anneal or melt the metal. Then there's a tiny lever here where you can adjust your gas flow. And honestly, I can't tell you the last time I had this adjusted to anything other than maximum gas flow. It's been so long that I actually forgot this lever existed until I was sitting down to edit this video and saw the lever on the footage and was like, oh yeah, I should mention that. This torch reaches a max of 2,450 degrees Fahrenheit. The reason I have 2 torches is it allows me to bring my metals to a hotter temperature with more consistency without having to involve a whole acetylene torch setup. With an acetylene torch, you can reach temperatures of 4,470 degrees, but that does require a more intense and more expensive setup. This entire butane torch setup costs maybe maximum $75 with just 1 torch, whereas an acetylene torch setup without the acetylene itself costs upwards of $200. Now let's talk briefly about our butane. When working with a butane torch for jewelry purposes, quality is key. You want to be sure you buy butane that is of the purest quality, because imperfections in the butane will cause minor sputtering, which results in heat inconsistencies, and also will damage and clog your torch, and altogether shorten your torch's lifespan. This butane I just get from my local smoke shop, of which in Seattle there are plenty. Next up, let's talk about this fire brick. There are plenty of different kinds out there, and of the few I've used, this one works best for my personal needs. This specifically is a vermiculite soldering brick. The purpose of a fire brick is to not only absorb the heat so you don't burn something under your metal piece to a crisp, but also to evenly redistribute that heat. If you're doing fusing or soldering, heating up your entire component at an even rate is key, and having a fire brick that can redistribute that heat on the underside of your piece as evenly as possible is really important. Now your fire brick will absorb a lot of that heat, but just to be safe, you'll want some kind of surface below that fire brick that can absorb any spillover heat. I just used this super inexpensive baking sheet I got from IKEA, but getting any kind of baking sheet from your neighborhood secondhand store will do. Alternatively, if I'm not doing the setup on camera, I'll actually just set up my fire brick on my stovetop burner, because that's kind of the perfect setup. The stovetop is literally built to handle heat, and there's already a built-in ventilation fan above it, so why not? Next up, we'll talk about our quenching bowl. You can buy a special quenching bowl, but really all you need is some kind of heat-resistant bowl like metal or glass that is big enough to fully submerge whatever piece you're working on. And be sure you fill your quenching bowl enough so that when you drop your piece in, the entire piece will be submerged. Finally, let's talk about these pliers. These are special cross-locking pliers that are for metalwork and torch work. And as much as I love mine, I used to use just a cheap pair of chain nose pliers that I didn't use for anything else. I still have those somewhere, they worked just fine, but you want this pair of pliers to be dedicated for torch work because between the heat and the water and various metals, they will get destroyed. You want your regular jewelry pliers to be clean and smooth so as not to mar your work, and your torch pliers will get trashed pretty dang quickly. If you do choose to go the route of using a cheap pair of chain nose, just be sure you get a pair that have a non-metallic grip. You need that insulation because your pliers will heat up very quickly with all this torch work and can definitely burn you. Now that we've gone over tools extensively, let's talk about filling your torch and getting started. There's this little hole in the base of your torch where you insert your butane. Make sure you insert your canister nozzle straight into this hole. If you enter at an angle, your butane will sputter out and not actually fill your torch. You should hear a pressure release sound and a subtle hissing as your torch fills. And once your torch is full, you'll feel and hear your butane start to sputter. As soon as you feel or hear that sputtering, stop filling your torch. Overfilling your torch is definitely no bueno. Butane naturally evaporates quickly enough that you won't need to worry about wiping down your hands or your torch canister, but I always recommend 1, filling your torch a distance away from your setup, and 2, allowing your torch to settle for at least 5 minutes before you do any work with it. Now once your torch is settled, just make sure the rest of your setup is all in place and we're ready to start. A great place to start with torch work is making your own head pins, and this is because it's a simple way to get used to how your torch works. Now I'm sure you've already noticed this camera setup's a little different from what you're used to, but I don't want my camera directly above me because the heat above my fire brick and above my torch setup will travel. I don't want to risk damaging the camera, and for the same reason not having my camera directly above or in front of this setup, you will want to make sure that your work area is free and clear as well. Today I'll be using some 22 gauge copper wire to make head pins, so I've cut several lengths of wire about 1/2 inch to 1 inch longer than I want the final head pin to be. I'm going to turn on my torch by pulling down the release, hitting the ignition, and then while I'm still holding that ignition, I'll hit the lock on the side. While holding that lock down, I can release the ignition and then release the lock itself and the torch will stay lit. In order to turn off your torch once it's lit and locked, just hit your ignition button again, and it will click off. Now I'll put my torch back in its stand for maximum stability, make sure it's pointed away from myself with the flame directly above my fire brick. It's hard to see on film here because of all the lights, but the flame will essentially have 2 main parts to it, this outer flame and this inner flame. Right at the tip of this inner flame, which is going to be blue, is where you'll get the most heat. So that's always where you want to position your piece. Now with the way metal works, it's like any other solid where it heats up to a point where it melts and then becomes liquid. One thing to keep in mind though is that when metal becomes molten, it naturally balls up and will move towards the hottest point, usually where your flame is pointed. I'll demonstrate this a little bit and show you what I mean. This can show you why it's so important to heat your pieces evenly, because otherwise you'll be left with potentially undesirable blobs in your pieces. So what does that have to do with making head pins? With head pins, you're essentially creating tiny balls of metal at the end of your pins. I'll do this by starting with a straight piece of wire, and I'll hold that wire perpendicular to the flame with the wire end right at the tip of that first most intense blue flame. I'll move the wire up and down a bit to heat the entire thing, and then I'll concentrate the heat just at the bottom of the wire. Your ball will form rather quickly, and as it does, you'll want to start moving that flame up the pin. You want to work quickly but carefully. If the ball gets too big, it will get too heavy and drop off, and you'll have to just start over again. If you don't hold your pin fully straight, your ball will be off center because the molten mass will give into gravity and favor whichever side your pin is leaning towards. And if you move your head pin too fast and don't heat it properly, you may get this weird little nubbin at the end of your pin, which isn't the end of the world because you can just snip it off and file it down, but it does go to show that you're inconsistent with your torch work. So be sure you're heating your pin evenly, holding it straight, and moving your pin at a proper pace to maintain a perfectly round ball at the end of your pin. Now once you've made your pin, you want to drop it in your quenching bowl. Make sure it's fully submerged and then you can immediately pull it out. Quenching hot metal is more than just cooling your metal down with water, it's an actual molecular process. When you quench your metal, the water shocks the atoms of your piece back to their neutral state, so instantly after your metal is fully submerged in water, it is safe to handle with your bare hands. Now that I've talked you through the whole process, I'll just take a little bit and show you through a few more times. Now technically these are called ball pins. Head pins are known for having a flat end that fits seamlessly at the end of your beads, but no one I know has ever gotten mad about calling these head pins. It's kind of like calling a square a rectangle versus calling a rectangle a square. This ball pin could technically be called a head pin, but a head pin like this wouldn't be classified as a ball pin. Now thank you all so much for tuning in today. Please let me know if you have any comments or questions down below. Also let me know if you're personally offended by me calling these head pins versus ball pins so that I can tell you that you need to take a chill pill. And with that, take care and bead well.